All right. So this section, the first half or sort of 3/4 of the section is focused on factoring. So factoring is a strategy to take something and turn it into a product. And you do this all the time with numbers. 6 we think of as 2 times 3, right? And so we may or may not call it this, but this is the factored form. It's the same value as 6. But being factored gives us some different ways of working with it, some advantages for multiplying or dividing when we can see these numbers as factored. So we want to be able to do the same things with polynomials. So we did a little work with polynomials in our last section, multiplied them, added them, talked about their degree, those sorts of things. And now we're adding this other strategy, which is called factoring. And so within factoring, there are a lot of different types of strategies in factoring that we can do. All of the types of factoring, we want to start with what's called the greatest common factor. So I'll start with this, and then I'll move to some binomials. So the greatest common factor, the strategy there is to pull out something that is common to all the terms. We use this, the GCF. Shows up better than the pencil. So for example, 3x squared plus 9x, that's a binomial. And I notice that within each of these terms, there are common factors. So both of these have a 3, and both of them have an x. So the GCF here is going to be 3x. And what I can do is I can rewrite that original binomial as 3x times x plus 3, right? And I can check that because if I multiplied it back together, I should get right back what I started with. And they are the same things, but this one is written in a factored form. It's one thing multiplied by something else. And it turns out that has some important improvements for us compared to the unfactored form. And these can look a little bit more complicated. 12x to the 7th minus 8x to the 5th plus 40x cubed. This is a trinomial. There are 3 terms there, but we still can think about factoring and pulling out this greatest common factor. So when we do that, we just look at the numbers first. Each of these numbers is divisible by 2, but we can do better than that. They're each actually divisible by 4 as well. So that tells me there's a common factor of 4. So I'm going to pull that out. And then when I look at the x's, they all have at least an x cubed, right? X to the 5th and an x to the 7th. So I can pull out an x cubed. And then whatever is left, I'm imagining I'm going to distribute this back through, and it better give me what I started with. So in order to get a 12, this has got to be a 3. And in order to get x to the 7th, I need an x to the 4th. And that's why we did some work with exponents before, because we wanted to make sure we could understand that we add the exponents there. So here, in order to get an 8, I need a 2. In order to get x to the 5th, I need an x squared. And finally, I need a 10. So again, I'm imagining that I'm taking this, distributing it to get what I started with. So any factoring problem that you see, you will always want to start with the GCF. It's like a universal strategy. Any questions about that one to start with?
Yeah, I have a question.
Yeah, great.
So you have to use the number that they have in common to divide for the binomial?
I mean, yes, I'm not actually really dividing so much as using division to see what's common to both of them. So if I'm able to divide them both by 3, that means they both have a factor of 3. So I guess it's a little bit like how we think about finding the common factor of 3. There are a lot of different ways of thinking about it and still coming up with that common factor of 3. So in this case, the important thing is not so much how we think about it, like is it dividing, is it multiplying, but that we're able to find some way to see what's common to all the terms. That got at your question at all, but like when I look at 12 and 8, I can see, because I think of 12 as 3 times 4 and 8 as 2 times 4. That tells me there's a common factor of 4 within those, and certainly the same thing there. Was there more to that question, or?
No, that was all. I was a little bit confused how on my math lab how they were getting the numbers.
Like this 4 here.
Yeah, I did it differently and I keep getting it wrong because I'm not doing it the way they want to. And I didn't understand.
Yeah, I mean, it is the result that they and myself care about, rather than the process here. Sometimes with problems, we're very interested that you do things in the right process. But for factoring, it really does turn out that the result is the thing that matters. The result is the thing that matters the most with factoring. So there's many different strategies and ways of looking at the problems. And other people, you may have learned some different strategies at other times, and those are all fine. Like anything that works is fine. And if, like you said, if it isn't working, then we've got to examine what's off about it. You know, what's nice is that we have an easy way of checking if we have the right thing. By multiplying it all out, we should get back what we started with. And if that's the case, then we do have it factored correctly. The one thing to be careful of is we want to make sure there are no common factors left over. So I see like the 2 and the 10 both have a factor of 2, but 3 does not. So we're okay here. We don't have anything else that we could pull out. Sometimes that is a problem or a way of getting these wrong. Okay. So the first homework is this greatest common factor. And then it also includes a strategy for factoring 4-term polynomials. And then the next couple homeworks are different ways of factoring 3-term. Then we go to 2 terms, binomials. And then finally, at the end of the section, we use that factoring to help us solve some equations and answer some application type problems. So it doesn't matter so much order which order you attack those different strategies in. So let's take a look. There's a question on binomials. So let's work through our strategy here for binomials. So here's a binomial, two terms. And it turns out that when you have a binomial that fits this form, a squared minus b squared, that there's a formula for that. That's going to be a plus b times a minus b. And you can check this just like we always do when we factor. We're sort of going one way and multiplying is going back the other way. So when I multiply these, I get a squared and I get a minus ab and a plus ab. And we may recognize this pattern from multiplication, that those middle terms are going to cancel here. And then I get a minus b squared. So these really are the same things. This is factored form. So this x squared minus 9 I can rewrite or factor like that. Here's a different example. So when we look at this one, you want to see two terms again, just like the last problem, but it's not the difference of squares right now. 2x squared isn't a perfect square because of the 2 there. But we notice there's a 2 in both of these terms. So we can pull the 2 out in front, which gives us x squared minus 16. So we pulled the GCF out, and now we can continue to factor, and now we can see this is the difference of 2 squares, just like the last problem. We keep the 2 there, and this will now become x plus 4 times x minus 4. When we multiply those, we get our original problem, right? But now this is written in factored form. Questions on that part?
So when you multiply, do you multiply the whatever is in parentheses first?
Like if I were to multiply this out to check it,
Yeah.
you can multiply in any order. So I could multiply these two together and then with this. But it is nice to multiply these two parentheses together first. That's going to turn it right back into this binomial. So if I FOIL these two together, the same pattern is going to happen as with right here. The middle terms are going to cancel. And I'll end up with x squared minus 16. And then I can multiply it by the 2 to get me back what I started.
Okay.
So you can do it in any order, but this sort of plus and minus combo is a really nice combo because it simplifies down pretty quickly. So I like to multiply those parts together first. But remember, the goal is to get to here, right? This factored form. The multiplying is a nice way of checking it, but it's not necessary. Other questions on this one? Okay. So there are some other versions here of binomials that we want to talk about. Here's a different style, x squared plus 4. it often feels like this should factor kind of the same way, or that you can somehow get around it and make it factor, but the plus turns out to mess up the pattern. And this type of polynomial is prime. So prime things can't be factored or broken down anymore. So as a general rule, anytime you have a squared plus b squared, you're going to have a prime polynomial, one that doesn't factor. We will also see, not as common, but we will see some cubes as well. And these have formulas: a cubed plus b cubed and a cubed minus b cubed. These will also both factor in a slightly different way. This is going to be a plus b, a squared minus ab plus b squared. And this would be one to keep in your notes. It doesn't come up all that often, so it's not that worthwhile to memorize it. Plus ab plus b squared. So for example, if I have 8 27x cubed. That's a binomial. It's two terms. It's not the difference of squares or the sum of squares. It is the sum of two cubes. This is really 2 cubed, and 27x cubed is 3x cubed. So that tells me it's going to factor according to this pattern. And once you identify that, you're just plugging 2 in for all the a's and 3x in for all the b's. So it's 2 plus 3x times 2 squared minus 2 times 3x plus 3x squared. You see, I'm just following the same pattern from up here. Now I can do a little bit of simplification here, not much. 4 minus 6x plus 9x squared. Questions at all about that? Okay. The binomials are actually relatively nice for us because they have these kind of specific formulas. Like when you fit these patterns, you immediately know what the answer is going to be. So it's especially true with these, right? Like if I see this pattern, it tells me directly what the values are going to be when I factor it. Unfortunately for us, trinomials are a little different. So trinomials There's a form there, but it's still hard to know how all the pieces go together. So let's talk a little bit about trinomials. So this would be a typical trinomial. You can see, right, that there's three terms there, the x squared term, the x, and the constant term. And our goal is to try and factor this. It turns out that this trinomial will factor, if it factors, it's going to factor as two binomials that are multiplied together. Remember, when we multiply binomials together, we would FOIL them. And so the first terms here and here, it turns out are going to multiply to give me this x squared. The only two things that multiply to give me x squared had to be x and x. So for this trinomial, these have to both be x. And the last terms here, when we FOIL, are going to give me this 12. That's the last terms. And turns out that there's a couple options for 12, but not too many options. It could be 1 and 12, could be 2 and 6, or it could be 3 and 4. So one strategy is to just pick each of these three pairs and sort of see if, when I put one of those pairs in and FOIL it together, do I get this 7x in the middle? So let's just see how it works here. I'll put in +1 and 12 and see what happens when I FOIL that together. I get x times x, which is x squared. That's just what I thought was going to happen. And the last term is 1 and 12, so that's 12. That's also what I thought was going to happen. I also get the outer terms and the inner terms. So notice those are going to be 12x and x, like 1x. And so when we FOIL this type of two binomials together, what we see are these inner and outer terms. They're going to add together. And in this case, they give me 13x. So this, when I multiply it out, does not give me what I wanted. That's okay. With factoring, we are not afraid to try things and get it wrong and then adjust it and try and adjust it so it turns out to be right. Notice this 13x is really the 1x plus the 12x. So if you notice that pattern, I think you can figure out what the answer should be, right? It shouldn't be 2 and 6, because if those give me my middle terms here of 2x and 6x, that would be 8x, also not what I want. But 3 and 4, that seems very promising. Let's check it and see if it works. I don't really need to check the first term or the last term because I've chosen ones that are going to give me the x squared and going to give me the 12. I don't have to worry about those anymore. And we can imagine or see here that the 3x and 4x are going to give me what I want. So this is the factored form that I'm looking for. There's lots of different ways of looking and thinking, and there's a box method, and there's all kinds of different strategies I've seen, and I'm sure there's lots of strategies I've never seen before that people also use. Any strategy that works for us here and works efficiently is going to be a fine strategy. What I did was really just a trial and error method. I just picked different options, plugged it in to see if they could work. Now, once we've done that a time or two, excuse me, we're going to be much better at guessing the right combination right from the beginning. So knowing what we know now, we might have not bothered with this 1 in 12 option, knowing that wasn't going to work, and we could have gone right to the 3 and the 4 option. Questions about this first example? Okay. So a lot of times I'll sort of keep doing a bunch of examples kind of just like that, and you guys will kind of get a pattern and a routine. But there are some other quadratics that we want to do too. So I actually kind of like to mix it up a little and before we get too locked into a particular routine. So this is also a trinomial. I said quadratics, those are a type of trinomial. So this is a trinomial, 3 terms. I want to factor it just like before. The difference, and it turns out it is a significant difference, is this 2 on the front. Because of that 2 on the front, my values here and here are not just x, but one of them has to be a 2x and an x. That's the product that's going to give me the 2x squared. And this 2 now kind of changes the pattern when I FOIL, because when I FOIL, this 2x is going to get multiplied by whatever number is over here. Whereas this number right here, this constant value here, is just going to get multiplied by a single x. So now all of a sudden, these are not perfectly symmetric. One binomial is a little different than the other binomial. I still have to get a 6. And the only way to get a 6 is a 1 and a 6 or a 2 and a 3. It's harder to tell which pieces are going to work for us than it was in the last one. So we can always fall back on that trial and error method. So let's just go through that like we aren't anticipating what's happening. Again, I'm very focused here on trying to get a 7x as my middle term. And you might think, well, this looks pretty good. 1 and 6 looks good, but it's going to be 1x. And then 6 is going to get multiplied by 2. So that's actually going to give me 12x. And that's not what I want. That's 13x. That's not going to be a 7x. I could flip it around and put a 6 here and a 1 here. That's going to give me 2x and 6x. It's, I guess, kind of closer, I guess, but it's still not 7x. So that pattern doesn't work. That's okay. Just keep trying. I wish that I had stuck with the pencil here, right? So I can erase, but okay, I got lots of paper. I start over with 2 and 3. I'm imagining one of these numbers gets multiplied by 2, and I want to get to 7. So if you're thinking that way, I think you could see that the 2 has to go here, and the 3 has to go here. 2x times 2 is 4x. And 3x, and that does give me the 7x I wanted in the middle. I know I'm going to get the 2x squared, and I know I'm going to get the 6. So I've cracked it, right? It was a little puzzle, and I cracked it.
Why did we switch the numbers this time?
Why did I put the 3 here?
Yeah, and the 2 over there.
Because before I put the numbers in, and this, in the beginning, you may not be able to kind of guess what's going to happen, and you just have to put the numbers in and see what happens, right? And that's totally fine. But as you do a couple of these, you're going to start to get a feel for how it goes. And so I was anticipating what's going to happen when I FOIL these out. And I was anticipating that if I want these to add up to 7, I want to multiply the 2 times the 2x, because that would give me the 4x. And the 3 times the x gives me the 3x. So that's why I picked the 2 here and the 3 here. The idea is like, I don't want to go through all the possibilities, right? I want to get the right answer the first time, because then I'm done with the problem and I can move on to other things, right? Or Netflix or something. But I sometimes don't know how it's all going to work out. So I got to try things until I get to the right combo. But you can be a little strategic with your guessing, right? And be trying things that seem like likely options. Does that make sense?
Yes, I understand now. Thank you.
Yeah, and it's one of these skills that just the more you do it, the better you get at seeing how the pieces fit together. And the better you are at foiling, the better you are at factoring, because it's really reversing the process of foiling, right? I'm really foiling a lot in my head when I'm factoring these, and you may need to write down more. You may be able to do it in your head. All of those are perfectly good options, as long as you can get yourself to this factored form. Okay. Do you see, it's important to me that you see these two problems are related to one another, but they're slightly different. This one is definitely harder because of the 2 in front. That's not said to intimidate anyone, but just so you're aware of the situation, and don't think that it's going to be kind of, maybe easy to see how the pieces fit together. It's not always. It's sometimes hard to see how those pieces fit together. But if you keep trying the options, you'll find a way that works. Other questions at all about this one or either of those? Let's try 6x squared minus 9x minus 15. I think this works. So it's a trinomial, 3 terms. And if I give this to students on a test or a quiz, many of them start right in with trying to figure out how this fits together, right? It's a puzzle. You want to solve the puzzle. The challenge here is that 6x is sort of even worse than the 2x, because 6x could be 3x and 2x, but it could also be 6x and 1x. So now I have a whole bunch of new possibilities and a whole bunch of different things to try. I'll get there eventually, but I'm not loving it, right? It seems perhaps difficult. Can anybody see a way of attacking this problem that's gonna sort of save me from working through all these different possibilities? Anyway. It's hard over Zoom, I know. What do you notice about each of these three terms?
They can be factored by 3.
Exactly right. They can be factored by 3. There's a greatest common factor. So let's not do this. Let's start by pulling out that 3. Notice I still have a trinomial that I need to factor, but my life has improved significantly by pulling out that 3, because now this is much smaller. 2x squared is a lot easier than 6x squared because there's only one way to get 2x squared. 2x and x. And 5 or minus 5 is a lot better than minus 15 because again, there's only one way to get 5, right? It's a prime number, 1 and 5. Now, to make it a negative 5, one of these has to be positive and one of these has to be negative. And one of the numbers is going to get multiplied by 2. So there's still a fair number of choices and different things going on here. But it's a significant upgrade from the first version of the problem. So always look for that when you're doing any kind of factoring. If you pull out the GCF, it's going to make your life a lot easier. Now, some of you may just be able to see which part goes where and how it's all going to fit together, but many of us aren't going to be quite sure how it all fits together. And so that's okay. You just got to try something. I do notice that if I put the 5 over here, I'm going to get a 10x, which is going to be a little bit too big to get me to this minus 3x. So with the idea of guessing a likely answer, I pick a 5 and a over here and a 1 over here. Now I want to get a negative 5. So one of these has to be positive and one of these has to be negative. Again, you can anticipate what's going to happen and figure out which is which. But if that seems hard or you're not sure, don't worry, just try something. So I might just try a plus and a minus here. That's going to give me a 5x minus 2x, which is 3x. But I wanted negative 3x. So that tells me I just mixed up the signs. It should have been a +1 there and a -5 there. That'll change these signs. And that'll give me a negative 3x. That's what I want. Any other questions about this one? Okay. The trinomials are the most common factoring that we do. And so we do want to make sure that we are able to do these. It's fine in the beginning if they go slowly and you have to try a lot of things. think of that as an investment in the problem, and that over time, they will go more and more quickly as you have seen more and more of these patterns and how they fit together. There are always some that are just hard for whatever reason. That's true for me as well as students. There's ones that, like, for whatever reason, the numbers don't seem like they fit together for some reason. And so I just fall back on trial and error when I do those. Okay, there's no magic strategy that I'm using. I'm doing the same things that I'm telling you about, which is trying to foil it and fit the pieces together to get back where we started. That's what factoring really is. There are a number of other examples in the D2L videos. And so I would encourage you to watch through those if you're still feeling shaky on these at all. Some of you may be feeling comfortable with them, and that's great. You should charge right into the homework. But if you're feeling a little shaky, more examples will help you start to see those patterns. And again, if you have a different strategy of factoring, someone taught you the box method or a grouping method, as long as it's working for you, that's going to be totally fine too. I have no issues with other people using other strategies. Okay. So those were the main topics that I wanted to cover today. Close here, 7:15. So I'll go ahead and let you go, but if you had some additional questions or any homework problems, certainly stick around and ask those. I'm happy to talk about them. Otherwise, if you do go, just make sure that you are starting your work now. I can see again from the homework that many of you, that's the case. So it's a little dangerous to take a week off and now you have, maybe this MEA break, perhaps. I don't know if you have that or not, depending on what your other classes are, but you've got to be making progress so that you can get through all the assignments in time, right? You don't want to save it till the very end. That's dangerous and stressful, right? We want to avoid that. So have a great week. If you don't stick around, I am around basically this weekend, so I will be answering any questions that come up. I'm still not getting a whole lot of questions through my math lab. Makes me a little nervous sometimes. Maybe things are going great and that's fine. You don't need those questions, but if things aren't going great, that's a first thing to try, right? Is ask a question on the homework so I can give you some feedback on that. Okay. So have a good week, a productive week, and I will see you on Wednesday next week if I don't hear from you before then. Okay, so take
Have a
care.
good week.
Thank you. You too. Bye-bye.